Okay, so what you should have done was just to go up 2, down 2, right 2, left 2, and draw your circle. All right, now I want to draw squares that are perpendicular to the x-axis. Now, this time, I mean, it's not just a semicircle. It's the whole circle, so my square is going to be like this. Okay, I'm trying to make it look 3D. So that's your square. Not drawn to scale. Okay? So what's the area of a square? Side squared. So I need to know the measurement of the side, which would be from here to here. Ideas? I heard somebody, I heard it. Say it louder. Who said it? I heard it over there. Somebody said.
I heard also.
Also, you said 2 times what? Yes, 2 times the equation. From here to here, we know that is the equation. From the x-axis to that point, but I need it from here to here. So it's double that. So if I knew that this from here to here was 2, then what would it be from here to here? It would be 4, but it's not because this moves, you know. So it's not right there. So it's 2 times that equation. Now what does my equation need to be in terms of? X. All right, so I'm going to take, this is my side. I'm first going to put this in terms of x. So y is going to equal the square root of 4 minus x squared. I'm not worrying about a plus or minus there because we're talking about a length. I shouldn't have said, that's not the side. The side would be 2 times that. I'll put that up there in a minute. So one side would be 2 square roots of, why did I put a 16 there? Okay, so now how would you set up the volume for that? Write your equation for the volume now. Let me remind you that volume for cross sections, volume is the integration from something to something of the area d whatever, x or dy. And I have the area, side squared. So for your equation, anybody want to call it out? I'll do this part. What are my upper and lower bounds? -2 and +2. And then your side squared dx. Okay, so from here, you have to integrate it. But first of all, let's square it to get rid of that radical. Don't forget to square that 2. When you square that 2, you're going to have 4. And then when I square that, that removes the radical. You can distribute that 4, or you can take the 4 out. I'm going to take it out. And then I'm going to go ahead and integrate this. So 4 would be 4x. X squared would be 1/3 x cubed. From -2 to +2. So we're going to substitute your upper bound, which is 2. 4 times 2 minus 1/3 times 2 cubed minus, now the lower bound, 4 times negative 2 minus 1/3 times negative 2 cubed. Let's see, that's going to give us 8 minus 8/3. Yes, you. Was it? Oh. Negative 8. That's going to be a negative 8, so that's going to make that positive 8/3. So I have 4 times 8 minus 8/3 plus 8 minus 8/3. And you end up with 128/3. That's the same problem as homework? Okay. So do you see the difference in this one than the ones we did yesterday? Most of the ones we did yesterday went directly to the x-axis. And most of the ones we're going to do today are going to go from like one point on the graph to another point on the graph. Okay, go ahead and see if you can sketch the next one. Okay, is that your sketch? Y-intercept at -3, a slope of 4/3, so I went up 4 and over 3. And that's in the wrong place. Okay. We're only looking at the part that's in the 4th quadrant. Okay, I need to make that bigger. Okay, so we're only looking at what's in the 4th quadrant. Now, the semicircles that we're gonna have the cross section of are perpendicular to the y-axis. So there's a semicircle. Remember, there's lots of them, so you can draw more of these if you want. You can draw as many as you want. I usually just draw one, but there's a lot. I mean, because that's the integration is adding all of those areas together, so it's not just one of those. We just usually show just one. All right. So what area formula am I going to use? Okay, half of a circle, which is 1/2 pi r squared. What does it need to be in terms of? Y. So in terms of y, we've got y plus 3 equals 4/3 x. So I've multiplied each side by the reciprocal, 3/4. And then I'm going to distribute it. Now, I can find this. What is that distance? What is this right here? The what? Yeah, this line. All right, so that would be the diameter of the circle. Yes. Well, you always have to have the radius, so yeah. All right, so the diameter is that. So your radius would be half of this. So that's going to be 3/8 y plus 9/8. Okay, you set it up and finish it. Okay, so again, you're setting it up and then using the calculator to evaluate it. I don't think they would give you this to do as a non-calculator problem. I believe what they're going to do here is they're going to ask you, if it were non-calculator, they would only ask you to set it up, and you would stop there. All right, any questions on that one? Okay, try the next one on your own. All right, does anyone need more time to sketch and set up? Okay, I'm going to go ahead and sketch and set up, and then you go ahead and finish. All right. So another same circle. And equilateral triangles. And perpendicular to the x-axis. All right, is that what your sketch looks like? All right, what is the form, or do y'all need more time? Do I need to be quiet and let you have some more time? Raise your hand if you want more time. All right, so nobody needs more time. All right, tell me the formula for an equilateral triangle, the area. Square root of 3 over 4, side squared. And again, for the side, you're going to have to double that. What does it need to be in terms of? So this one looks a lot like the one we did earlier. So your volume's going to be the square root of 3 over 4. And then your side measurement squared. And your upper and lower bounds. All right, everybody get it set up correctly? I didn't double it. I need to double it. Thank you. All right, now that's set up. And when you finish, you should get 32 square roots of 3 over 3. This would definitely be non-calculator because it's not too hard to integrate that. Does anyone need to see the integration? It's okay if you do. Anybody? Okay. All right, now the last one. This is like that problem in your homework. Find the volume of a solid whose base is bound by blah, 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 blah. The cross sections are perpendicular to the x-axis are rectangles that have a height of 5. Okay, so I have a parabola and I have a line. Go ahead and sketch it. All right, everything needs to be in terms of x, and it is. And what are my cross sections? Rectangles. All right, so your rectangles are going to look like that. Okay, it says the height is 5. Would that be this? No, that's not this. We know that is not 5. So this is my 5. Now I need to find this. Because the area of a rectangle is base times height. And I know the height. Now I need to find the base of it. So how would I find that length? What did you say? You're going to have to subtract them. Like if you have, let's just look at this on a number line. I heard you said something. I mean, if this is 1, 2, and 3, and this is very, I mean, I know you can count the spaces, but if I wanted to go from here to here, 3 minus 1 is 2. Okay, so you're going to do your line minus your parabola. And that would be the base of your triangle. No, I meant to say rectangle. Okay, so your line was x plus 1 minus the parabola. Okay, very good, Justin. All right, that's the base, and the height is 5. So your volume is 5 times negative x squared plus x plus 2 dx. This one is, it's not hard to integrate, but you can put it into your calculator to integrate it, but what am I missing? I need to know my upper and lower bounds. And it's in terms of x, so what I need to know are those 2 points of intersection. Set them equal to each other. So I have x plus 1 and set it equal to x squared minus 1. What is this going to involve? Say factoring. Factoring. Good. Very good. So I have x squared. I bring this x over, minus x. Bring that 1 over, minus 2. Of course we're going to have to factor because there's 2 answers. We have 2, you know, your upper and your lower, or right and left in this case. All right, what does this factor to? Yes. So that means our x value of the points of intersection will be 2 and negative 1. Okay, go ahead and integrate that. That's what you should get.